Okay. We have the integral problem where we need to find the integral of secant to the sixth power of 8x, okay? So when it comes to solving these types of problems where secant has a power, there are some guidelines already written out for us to follow. So there's some rules for us to follow. And the rules involving secant simply states that if secant happens to be even and positive, what you do is save a secant squared x factor and then convert the rest of the problem to tangent factors. Okay. So diving in, what we're going to be doing is just rewriting our problem for the first few steps. So first and foremost, what it says is to save a secant squared x factor. So we're going to go ahead and take that out because I know that we can. And what that leaves us with is a secant to the fourth power with secant to the fourth power 8x. Okay. And this is the same thing as if we were going to, by chance, if we had x to the fourth, or rather, the rule with this is if we had, for instance, x to the third, and we're going to multiply it by x to the second, what we get is x to the fifth power. We add in this case. Okay. And another thing that you might see or you might have seen is x to the third power, and that entire quantity is being squared. What happens in that case is multiplication. So the 3 and the 2 would get you a 6. But as it applies to us, we have the first case where basically we're adding in the 4 and the 2 that we have. It's going to give us the 6 right here, which is what we're looking for. We're just rewriting it. So now that since that's true, we know that we've written it correctly. So moving forward, once we have a secant squared x 8x factor, which is right here, we're going to convert the rest to tangent factors. So it's important to recall the Pythagorean formulas. So one of the fundamental formulas is sine squared plus cosine squared is equal to uno. Okay. So if we're going to go ahead and manipulate this formula, which is really cool how you can do it. You can manipulate formula and then get a completely new formula. So if we're going to divide everything by cosine squared, what we get is a tangent squared plus a 1, which is equal to a secant squared. Okay. That's if we're dividing left side and right side by cosine squared. And this is perfect because it gives us exactly what we're looking for. We're looking for factors of tangent. So that new formula, that formula right here is exactly what we're looking for and exactly what we need. So we're going to go ahead and rewrite that. All right. So I'm getting ahead of myself just a little bit. I want to just explain the tangent squared 8x plus 1 gives us a complete, gives us two secant factors, okay? Just this alone gives us two secant factors. But what we're doing is rewriting this portion right here. Okay, so since this has 4 and this formula has 2, all we're going to do is double it up. All we got to do with ours is double it up. So that's exactly what we're doing. And of course, another thing to note is that we're rewriting the integral. So we're just going to bring this down right here. So now since we have this here, we know that we have to FOIL, which is just first plus the outer plus the inner plus the last products. First products plus the outer products plus the inner products plus the last. Okay, so we know that this right here, once it's foiled, is going to give us a 1 plus 2 tangent to 8x, because all we're doing is doubling the inside, and then we're going to square this last factor right there. It's getting kind of big, and I'm running out of space. Tangent, and since we're squaring that last factor, it's just going to be a tangent to the 4th power of 8x, all of which is going to be multiplied by our secant squared 8x dx. And I've ran out of room, okay? So pardon me for that. So now that we have that, what we're going to do, it's important to note that we're going to have to do some distributing. And since this portion right here is a factor, is being multiplied by the entirety of this, what we're going to do is distribute it in to our problem. Okay, so this is going to be multiplied by that, and then this, and then this. So we're going to be looking at 3 different integrals. And it's funny because the higher you go in math, the more you start to realize that the homework problems take up a whole lot of paper, like one whole page. Because they're so complex and require a lot of steps. That's all. This one is just a 2 tangent squared 8x, and we're multiplying it by that secant squared 8x dx. And again, I've run out of space. Oh my goodness. Plus the man, I really want to try to fit it in. But that's the tangent for 8x multiplied by the secant squared 8x dx. Now we're going to have to just take it one step at a time. That's the best way to eat an elephant. And this right here is an elephant. Look at these. This is just all one problem right here, and we're still going, you know. So we're starting with this one first. And this one is just the integral of secant squared 8x dx. So when it comes to doing integrals and how they relate to trig functions, a lot of times they're composite functions. So it's like integration is the opposite of derivation and or deriving, okay? So it's just important to, when you're integrating, just look for the most complex portion and let that be your u. So our most complex portion is the 8x because it's in the midst of the secant squared dx. And by the way, this can also be written as this. There's another way to write it. This is the other way to write it. But anyways, I'm not solving it like that. Anyways, our u in this case is going to be the 8x. And then our du, the derivative of 8x, is just going to be 8 dx. Now, I know that there is an 8 here and then a dx here, but there's also an x here, an x variable here. And I don't want to just say I'm done at this point in time. I want to put some respect on the letter x right there, okay? So I'm just going to go ahead and, if I can't do the entire thing of what's on the inside, then I'm not going to do it. So with that being said, I'm just going to go ahead and let this be my du over 8, which I'm solving, I'm getting because I'm dividing by 8. My du over 8 is going to be my dx. At least I can get a complete dx out of it as compared to just getting a single x. 8. It makes no sense for me to just substitute that in. So with that being said, I get a complete dx, and when I go to rewrite it, it's going to be a secant squared u times the du over 8. And then I can move the constant out. And what I see here is that the derivative is present. It's very important when you're integrating. You have to make sure that the derivative is present. Not only with integration, like something you gotta have is the u sub. That's usually what gets done. But you also gotta make sure that the derivative is present. If anything, remember that you gotta have your derivative present and do the u substitution. Okay. So, anyways, as we're moving forward, I know that the integral of secant squared u is just a plain old singular tangent u. Okay, and then the du changes to a plus c. The integral of secant squared gives me a tangent, a singular tangent. So if I continue with that, I have to change it back to terms of x. So my u is equal to 8x. And then this is going to be a plus c. So of course I can I can multiply it properly, simplify it again, and say that it's tangent 8x over 8 plus c. I can do that as well. It's the same thing. I'm going to leave that at the bottom. Because I have we got two more to do. We have two more integral problems to complete. So now we have this one right here. First things first, we're going to take out the constant. 2 is a constant. And then we're going to rewrite the problem. Okay. So then in this case, what we're going to do is let u equal to tangent 8x. Now we have to find the derivative of u. Our derivative of tangent 8x. Again, this is a composite function, is where you have this right here is a function all in itself. 8x is a function all in itself, and then tangent is a function all in itself, but they're together. It's like a Russian doll. So what you have to do is use chain rule. Chain rule is to derivative as u sub is to integration. They are like they're same two sides of a coin, okay? So basically with chain rule now, because here's what we're doing. Chain rule is the derivative of the outside, which is secant squared this, and we just rewrite that part. Take the derivative outside, rewrite the inside, and then you multiply it by the derivative of the inside. Which is just an 8. And of course, here's our dx. So yet again, here we are trying to figure out, well, how do we want to replicate our du when it comes to rewriting in terms of u? This is the problem that we're looking at right here. And we have to figure out how we're going to rewrite it. So yes, there is a secant squared and an 8x. And there's also a dx, but there is not an 8 dx. So that's fine. All we're going to do is divide by 8 on both sides. So here we go. Du divided by 8 is equal to secant squared 8x, which is multiplied by dx. And when we have this, that equals this. This right here equals this right here. So then we can do a direct substitution, okay? So now we're going to be rewriting in terms of u. So we have the integral. We have 2 on the outside, and then the integral of u. We have 1 u in our original u layout, but in our problem we have tangent squared. In the u layout we have a singular tangent. So all we're going to do is just go ahead and put a squared right there, and that solves it. Then we're going to go ahead and write our du down. It's actually a du over 8. And that's fine. We're going to bring out the constant. And then we're going to have this u squared times the du. And our derivative is present. Okay, so we're going to be able to go ahead and integrate. So now we have 1/8, and then a u to the power of 3, u cubed over 3, okay? And then we have our plus c. So it's going to look like this. Actually, this, you can cancel that out. That gives you a 4. So it's 1 u thirds u to the third power over 12, because you're gonna take the 4 in the denominator and the 3 in the denominator and multiply straight across, and you get a 12 right there, and then you add that c. In the end, these c's that we have, the constants, they don't really matter. So we're just gonna write it as 1c. So we've solved 2 integrals. What we're gonna do is go ahead and solve the last one, and then we're gonna be almost done. We're gonna be almost done with this one. Quite done, rather. We shall be quite done with this problem. Okay. So in this last portion that we have, this is the last portion. We're gonna let u equal to tangent 8x. And we're gonna let our du equal to derivative of the outside, because there it goes again. Derivative of the outside is secant squared (8x), secant squared, and then we just rewrite the inside. And then we're going to take the derivative of the inside, which is just 8. And since it's a derivative, we just write dx right there. Okay, so there's no way that we can fully substitute when we rewrite in terms of u, because it doesn't look the same. It will not be the same. It won't be equal to each other. It won't be a proper substitution. So what we're going to do is go ahead and divide by 8 on both sides, so that way we can have a secant squared 8x dx on our right side. Okay, so now as we're rewriting in terms of u, it's just going to be the integral of u. And let's see here, what's the power? Tangent to the 4th power. So the integral of u to the 4th, that's the proper way to rewrite it, which is multiplied by the du over 8. All right, so that's good, just like that. So all we do is take out the constant, rewrite the integral sign, the integral symbol, okay, and then we have this u to the 4th multiplied by the du. Then we can go ahead and integrate since our derivative is present. And what we're going to get is u to the 5th over 5 plus c. And if we go ahead and multiply straight across, we have u to the 5th over 40, because 40 and 5, 8 and 5 is equal to 40 when you multiply them. And then you have a plus c as well. So as you can see, as you might be aware, we now have 3 plus c symbols. All we need to do is just write one, okay? Actually, what I didn't do is rewrite in terms of x for this last one. Let me go ahead and do that. I'm going to have tangent to the 5th degree of 8x all over 40, and that's plus c. So if I take all of this, and I know it's scattered right now. If I take all of this, though, my answer is going to be I'm trying to write this as nice as possible. The final answer will be tangent 8x, all of which is over 8, plus tangent cubed of the quantity 8x, all of which is over 12, plus tangent to the 5th power of 8x, all of which is over 40, plus c. And that will be the final and correct answer. Thank you so much for joining me with this tutorial, and I hope to see you soon.